So the torque formula which we have seen, in what case is it applicable? Again, it is applicable when we are within the proportional limit, and there are some assumptions that the planes cross sections, they remain plane cross sections. Any lines which are parallel lines, they remain parallel, etc. Okay, so all the assumptions which we saw in bending moment, it is also applicable here, and it is applicable when the formula which we saw earlier is applicable only for circular cross sections. What if we have square cross sections or some other cross section? Then we need a different type of formula. We cannot apply the formula what we have seen earlier, and the maximum shear stress formula is given here. Now, for a rectangular cross section, where B is the longest side, this is the formula to be used. This is the maximum shear stress formula. And for a given length, what is the angle of twist that is given by this formula? The constants alpha and beta for various choices of ratio B over C, where B and C are the length of the bar cross section. Okay. Then based upon that ratio, where B is the longest side, we can use interpolation and figure out what are the alpha and beta constants, and then figure out what is tau max and theta value. So in your exam, if you are asked, you will basically calculate using these formulas here. Okay, so directly apply the formula. Next, in most of the problems, when you are using shaft to transmit power from one place to another between gears or pulleys, usually we will specify or give the specifications for the design in terms of power of the motor supplying a particular torque to a shaft. Okay, so a particular torque value or speed, etc. These are the values which we specify. So we need a relationship between power, torque, and speed of rotation. What is the formula? Torque times angular speed is the power. So here you can see in which units they are. These are in SI units. Torque times N, omega value is given in radians per second. You can also calculate from the power what is the torque in torque value. Let's see here. So this torque value should be, again, this is the inverse of it. So here we are again calculating it in SI units, except that we replace the angular velocity omega with RPM value. So when you have it in RPM value, then you have to convert it into radians per second, and this factor converts that into radians per second. Or otherwise you can directly take the RPM value and multiply by 2 pi over 60. This value will also give you, in the denominator we can replace that by rewriting torque is equal to H or omega, or we can write it as H over N times 2 pi over 60. So that also will give us the same value. Take 60 over here and replace it. Replace it as 60 over 2 pi will give you 9.55. We can also calculate everything in English units. If you are using in English units, then the power is related to the torque and N values by these relationships. You can also have force times velocity related to power. All these formulas will be provided in your exam if it is required. Okay, so this problem is, I will try to solve this problem next class, and because it is going to be quite longer. and this is a 3D problem, and you are asked to calculate what are these stresses at various locations here, maybe at the location A. Since this is a 3D problem, we have to express all the forces in vector form. It is better to express in IJK format so that we do not miss anything. And if you want to calculate what is the moment acting at A due to the force F, then we have to solve it in vector format by drawing, for example, the vector R here, and then figuring out R cross F. Using R cross F formula, vector format, we will exactly know what kind of torques, what kind of moments act at that point here. Okay, so if you use the vector format, you will not miss anything. However, if you try to do it manually, you may miss some moments acting at point A, some torque values acting at point A, etc. Okay, so we need to be careful here. So we will solve this problem next class. I'm going to stop right here because the time is up, and we will meet again on Sunday 8 a.m. Okay, see you guys then. Any doubts?
No,
If you
clear,
don't
Doctor.
clear, okay, so I'm going to stop right here.